What's up YouTube? I'm an average dad. In the last video I installed the beverage cooler cabinet and countertop for a dry bar in our basement. So in this video I'll show you how I made the floating shelf with integrated LEDs as well as the accent wall. So we'll jump into the floating shelf. For the material I'm using this edge glued spruce board. Others will use more exotic wood such as walnut or high quality plywood. My wife and I like the naughty appearance of this though, and it's only $21. While I do spend an above average amount of time on these projects, when it comes to my woodworking skills and tools, the name of the channel really is pretty accurate. Anyway, I'll use my table saw to rip down that board to the correct depth of the shelf, and then since I don't have a sliding miter saw, I will lay on the ground and try to match up those cuts. During this build, I referenced a video by Brad Rodriguez on Fix This Build That about a floating shelf with LEDs as well. It's an awesome video and I'll link it below, but I'll call it a couple differences between Brad's build and my build. First off is the construction of the floating shelf box itself. Brad uses a bunch of 45 angle cuts on each edge and then folds it together. It does end up looking awesome, but I don't have a nice shop or his woodworking skills, so I went with just a simple butt joint on the corners. So for the down LEDs, I'm going to use this aluminum channel. So we need to go ahead and cut a groove on the bottom piece for that to sit in. To cut that groove, I'm going to set my table saw to that height and then make a bunch of passes until the width is the same as that channel, and then cut it to length. I did cut it a little bit short so I could drill a hole and have a place for the wires to go inside the shelf. For the up LED lights, I'm going to use two LED strips that will be parallel to each other with a larger cutout and a custom diffuser. So I'm going to mark that cutout portion in the top shelf. Then I'll start the corners with my drill and cut out the rest with my jigsaw. These cuts were definitely not very straight, so I'll have to go back and fix that with my router and fence later. One of the downsides to using edge glued pine is it can crack along those glue joints. So we'll go ahead and re-glue that and then clamp it and let it dry. So like I said, these long edges especially were not straight when I cut them with my jigsaw, so I'm going to go back with my router and fence and straighten those up. The aluminum track that will go on the bottom came with a diffuser, but to diffuse these LEDs on top, I'm going to use this frosted acrylic I got from Menards. I'm going to cut a test piece so I can set my router to that depth and then cut the shelf for which the diffuser will sit on. So I'll do that and then test fit that piece. And clearly with how well my GoPro 5 focuses, you can see that we are in business. So next I'll go ahead and cut that diffuser piece as well as the shelf it will sit on. Once that's done, it looks like this. We'll go ahead and test fit our piece in there, and it fits lovely. So underneath that window, we need something for the LEDs to rest on, so I'm going to cut this 16th inch flooring plywood and then spray paint it white. I realized after the fact that the wood glue would not stick very well to the painted surface, so I had to go back and sand down the edges. Once that's done though, I'll glue it and clamp it into place to dry. While that's drying, I'll set up the bottom, sides, and front for assembly. You can see I have a hole for the bottom LED cable to come to the interior of the shelf where the Arduino will be. Then I'll go ahead and glue and nail those pieces together. So this brings us to my first large mistake.
You made a big mistake, huge!
Is using way too much glue and not wiping off the excess. So you can see here some of it is stuck to the paper that will cause me problems later. The aluminum channel does fit in that groove though, so that's great news. So go ahead and test fit the top piece. It was a little tight, so we'll go ahead and sand it down. Now we are ready to glue and nail the top portion. So just like the top piece, I'll go ahead and rest it on my workbench to keep it relatively square while I glue and nail it together. But you can see on the top, I once again put way too much glue and there was excess that the paper stuck to. My plan was just to sand off the excess glue, but I severely underestimated how long this would take, as well as the effect this would have on the stain still not sticking to those portions.
346 minutes later.
So learn from my mistake. Next time you glue a joint, wipe off the gosh darn excess. Alright, so at this point we're almost ready to stain. You can see here we have a couple cracks on either side of the shelf where the top meets the sides. I wasn't joking when I said my woodworking skills were average at best. You know, if it was a joke, it would have been funny. So to fix this, we're going to use Minwax Stainable Wood Filler to hide all that shoddy workmanship as well as the nail holes. And once it dries, I'll go ahead and sand it down once more. I'm going to use my router with the quarter round bit to go over all the edges. Get the height of the bit high enough that it would still give it a little bit of a hard edge and not a full round. Quick hot tip, if your table saw fence is hot garbage like mine is, if you line it up with something that is known to be straight on the table and then lock it in, you can then move it along the rails and it should be relatively parallel with the blade. I'm going to take my 1x3 that I'm going to use for the frame and run it through my table saw until it perfectly fits inside the floating shelf, like this. For the frame construction, I am going to follow what Brad did, having one main piece that goes along the wall with extensions going out from that, and then pieces in between those extensions. Once that's all cut, I'll go through and nail and glue each piece together. Once that's done, I'll test fit it inside the shelf, and it fits nice and snug. Which brings us to staining the shelf and my second large mistake. Using an oil-based stain, and originally I was using a foam brush, but it made it really blotchy, so I switched to putting it on with a sock, and that ended up looking a lot better. You can see the top here is extremely blotchy, and then the back looks a little bit better where I applied it with that sock. So fortunately, the next couple coats I also did with the sock, and was able to essentially kind of even out some of the mistakes made on the top. Now there were parts where the excess wood glue was still haunting me and the stain would not stick to it, and I did not sand it enough. So I ended up using some extra gel-based stain, which just sits on the top, and this was a poly and stain combination. But it was about the right color, and once I put the poly on the rest of the shelf, it blended in fairly well. So the polyurethane is just going to give it a satin clear coat that will protect it and make it look more professional. So I'll give it one coat of that, and then I will sand and vacuum off the surface, and then give it another coat to make it nice and smooth. The polyurethane dries a lot faster than paint, so to avoid having to clean out the brush in between each coat, this was my chip clip solution for that. So originally on the frame, I did just use nails and glue, but went back and added a couple screws into these supports. Unfortunately, where I'm hanging this, there's only a stud in the middle, so here I'll drill a pilot hole for this bolt, and then on the sides, I'll just have to use drywall anchors. After that, I'm going to router out a groove so the wires can come up the wall and into the shelf. For the accent wall the floating shelf is on, I'm going to use these faux brick panels. These are actually hand painted and made of foam, so they're really easy to work with. Normally they're around $100, but my parents had a couple extra from a project they did, so for me it was free $99. In order to make the placement of the shelf easiest, I'm just going to have one panel below the shelf and one panel above. So I'm going to go ahead and mark the stud and the anchor locations and then install the frame. Now it's time to talk about the LEDs. Real quick, we'll go over the overall setup. So we'll have the up LEDs and the down LEDs, which will be run by the Arduino circuit board. And then we'll have two buttons and a motion sensor, which will be used to turn them on and off. To power everything, I'm going to use a 3 amp wall brick, which will be important because the LEDs will draw a decent amount of current. So the power is going to run to all the components as shown. Just remember I drew one line to keep it simple, but that black line represents power and ground. Then there will be data lines running from both LEDs, the button, and the motion sensor to the Arduino so it can talk to all of them. LEDs and the Arduino are all going to be housed within the floating shelf. Another quick thing to note is I will wire the motion sensor, but I will set it up and program it in a later video. Lastly, I wanted this to be highly customizable so I could activate the lights with the buttons or motion sensor however I wanted to do it. But if you don't have the time to mess with learning that, you can definitely still make an awesome floating shelf with LED strips that are more plug and play. I'll link it to you down in the description below. So for the down LED, we want to avoid hot spots, so I'm going to install this cardboard spacer so I can put the LED on the side of the channel instead of the bottom. These are the LEDs I'll use, the link is in the description. These can be trimmed to size at the locations marked along the strip. Just be sure to note that the data will only flow in one direction and will be noted by little arrows. So I'm going to cut off this connector it comes with and then solder it to some wires that have header pins on them, which means I can plug them into the Arduino. So I'll use a soldering iron to solder these joints. It's really not that hard. I'm pretty bad at it actually. But once I'm done, I'll go ahead and wrap them in electrical tape to make sure they don't short out. And then cut the strip at the right length. And then I will remove the adhesive backing and put it on top of that cardboard spacer. So now you can see we have the LEDs in the channel facing to the side, which should help diffuse it better. So next I'll glue that aluminum channel into the slot in the floating shelf and then snap on the plastic diffuser that came with it. For the up LEDs, there'll be two strips in parallel that'll light up the same way. So I'll solder header pin wires to one of them and then small jumper cables to the other so that they both seem the same signal and power. Once I had all that solder, I put a little bit of glue to help out those solder joints, and then connected the Arduino circuit and wrote a basic program to double check and see if everything was connected, which it was. So now I'll remove the adhesive backing and go ahead and tape those down. Then I'll put a couple extra dabs of glue on both sides in case they get pulled a little bit. And then once those are done, I'll put the diffuser on top with a little extra glue and weight it down for it to dry. So to activate these, I'm going to have two buttons on this little box I made, which I'm going to magically paint the same color as the wall. And I know, my woodworking skills are only surpassed by my sweet editing skills. I thought about putting the buttons on the shelf itself, but wanted to go with the clean look of not having anything on the shelf, so this will just be hitting on the wall to the side. So I'm going to push in my 2 buttons and then put the wire harnesses on the back. Now the Arduino that is going to be running the LEDs is going to be inside the floating shelf. I do want to be able to reprogram it from time to time though if I want to change the color of the lights. So I'm going to chisel out this slot and then have an extension that I'm going to put in the side. It's going to be kind of an interference fit with some glue. And this way I can plug in a cable and reprogram the internal Arduino while it's in the shelf. A couple portions of the circuit will require resistors, so we'll go ahead and solder those now in line with the header pin wires. So now going back to the basement, I have wiring for the buttons up top routed, as well as for power and the motion sensor going down below. So I know this may look like a lot, but if we go back to the whiteboard diagram, it's really not too bad. We have power and ground for the 2 buttons, power and ground for the motion sensor, signal lines for both buttons and the motion sensor, and then power and ground coming up from the wall brick. I'll strip those as needed and then attach all the power and ground wires together with wire nuts, as well as attaching wires that can plug directly into your Arduino for all these signal pins. Now, it's definitely not safe and against code to hide high voltage AC lines behind anything. Since these are all carrying low voltage DC current, it won't be an issue to hide them behind the faux brick panels. So now I'll connect everything to the Arduino and test it out, which was very nerve-wracking. But fortunately, working carefully and slowly had paid off. Both buttons worked first try.
Yes! Yes!
Now that I know that's working, I will go ahead and wrap the whole Arduino in electrical tape to make sure none of the connections come undone. And then take off the protective coverings on the LED diffusers. I'll tidy up the wires going to the button with a cord hider, and then go ahead and nail in that top panel to the wall. Next, I need to put an extension box on this outlet so it can sit further away from the wall and flush with the brick panel. I don't know if that's exactly how you're supposed to use that extension piece, but if it works, right? With that done, we can go ahead and nail the bottom panel out. So now there's these gaps on either side of the shelf where the panels almost come together. So I just force fit some small pieces I cut into those spots. Later I'll caulk along the edge and then paint it to match the mortar, but honestly it looks pretty good as is. So here is the finished product. The total cost for this portion was $207, putting the total going from this to this at $860. At the time of uploading this, each button will cycle through 2 different color options for the respective LED strip. So for the downlights, it's a bright white and then a dimmer, warmer white, and then a long press will turn it off. This is the same for the up LEDs, except for the second color is a rotating rainbow pattern.